Okay, so what we've done is looked at how to break up rational expressions into these little pieces. And now we're going to look at how we find the inverse Laplace transform to go back from S land to T land. So if we know that the Laplace transform of little f of t is equal to capital F of s, then more or less the inverse Laplace transform of capital F of s is going to be equal to f of t. So this process can be undone. And in all of the examples we're going to be considering, we will just say they're always just going to be equal. This inverse Laplace transform is a linear function. And so what that means is that if we have a sum of terms, so that we are trying to take the inverse Laplace transform, that we can break up doing this inverse Laplace transform on each piece, and things like scalars can just be brought out front. So some common transforms, these are basically starting with the right-hand side of our equation sheet and saying, what did this come from? So the inverse Laplace transform of 0 is equal to 0. The inverse Laplace transform of 1 over s is equal to 1. 1 over s minus a is equal to e to the at. So basically you're looking at the right-hand side and just matching it with the left hand it came from. The one wrinkle with this is that we will often need to do a little bit of work to take our functions and put it into a form that matches what we see on our little formula sheet. So let's take a look at an example here. So here we have the inverse Laplace transform of 1 over s squared plus 4. I'd like you to take a look at these examples here, 8, 9, 10, 11, 12, and 13. And see, looking especially at the denominators here, do you see, and in general, just we're often going to be looking at where we see s's. Try and see which of these rules do you think most closely matches this.